Hi, this is Brandon Baines in the Math Department at Lipscomb University. Here to talk with you today about the definition of an exponential function. In this presentation, you'll learn how to recognize an exponential function by its equation. You'll also learn how to graph exponential functions using an XY table. An exponential function is a function of the form f of x equals a times b raised to the x power plus c. In this definition, notice that x, the variable x, is an exponent. You also have a few definitions on what x, a, b, and c can be. X is any real number. That relates to the domain of this function. We can actually allow x to be any real number, and we can compute a y value for it. A is also allowed to be any real number. So this is just the coefficient in front of b to the x. And b is any real number greater than 0, but it excludes the value 1. You might consider if x were 0 or if x were 1, or excuse me, if b were 0 or if b were 1, then we would have things like 0 squared, 0 cubed, and so on. All of those values are 0, so that function just wouldn't be very interesting, and it wouldn't be an exponential function anymore. If b was the value 1, then we'd have things like 1 squared, 1 cubed, 1 to the 4th. And again, all of those numbers are just 1. And so again, the function would not be exponential at that point. C is also allowed to be any real number. When we think about the values that this function can give, we'll actually find that C is going to be what's called a horizontal asymptote. That is the equation y equals c. We don't talk about horizontal asymptotes very much in this class, but it's just to note a horizontal asymptote is a horizontal line that the y values get infinitely close to as x goes toward infinity or negative infinity. If we check the graph below, we'll see that as our x values continue to go to negative infinity, this graph its y values are getting smaller and smaller, and we can't see what's happening on down the road towards negative infinity, but since this is an exponential function, we'll know that the y values are going to get closer and closer to 0 on this graph. So what's different? Well, we saw it on the previous slide. I'll go back to the previous slide. That graph there certainly looks a bit different than any of the graphs we've looked at previously in this course. Linear functions, graphs are lines. Quadratic functions, the graphs are U-shaped. And this shape, of course, is different. So that's one thing. Another thing that's different, and this is maybe one of the key aspects that makes it different, is that the exponent is the variable. In the other functions we've talked about in this course, the variables have been the base. We've had x squared, 2x plus 1. But now we're talking about things like 2 raised to the x power. Well, this changes how the y values behave, how they change over time, or over as x increases or decreases. And in fact, it gives us the type of changes in our y values that represent rapid growth or slow decay, depending on which part of the graph we're looking at. So it's going to allow us to model those kinds of growth scenarios. And that's something we couldn't do with linear and quadratic functions. The number e is often used when we work with exponential functions. E is an irrational number that's approximately 2.718. Its formal definition is the limit as n goes to infinity of the expression 1 plus 1 over n raised to the nth. We'd normally cover that in a calculus class, how to evaluate that limit. E is often called the natural base, called that because it's often used to model these natural growths and decays that occur in nature. To evaluate expressions that use the number E, you can either use the TI-83 or 84 calculator by pressing second and then the LN button. The LN button is the third button from the bottom on the left. You can also go to Wolfram Alpha and type in the expression you're wishing to evaluate using E raised to whatever power, and it will evaluate that for you. The natural exponential function is just like any other exponential function, except that its base is the number E. And so we see here that we have f of x equals a times e to the x plus c. A is still any real number. X is still any real number. C is also still any real number. C will still represent the horizontal asymptote for the function. So if C is 0, then the asymptote is y equals 0. If C is 2, the asymptote is y equals 2. Let's take a look at graphing the exponential function using an xy table. We'll consider the function f of x equals 2 to the x. So we know that the horizontal asymptote of this function will be y equals 0 because the c value in our function, 2 to the x plus c, is 0. There's nothing there. It's plus 0. So y equals 0 will be our horizontal asymptote. We'll also see that in our xy table as we evaluate these function values. I chose -3 to 3. I really chose these values so that we could have lots of examples on how to evaluate 2 to the x, making sure that we cover that, and also so that we can kind of see where this horizontal asymptote is coming from. So when x is -3, we would do 2 raised to the -3rd power, which is 1/8. When x is -2, we would do 2 raised to the -2nd power, we would get 1/4. To the -1st, we would get 1/2. To the 0th, we would get 1, and so on. As we take a look at the behavior of these y values as x decreases, that is, as x goes from -1 to -2 to -3, we'll see that these y values are getting very small. However, these y values are not negative, right? They're still positive numbers. And this is where our asymptote comes from. If we were to evaluate when x is -4, if we were to put that in our table, we would have 2 raised to the -4th, which would be 1/16, 1/16. And again, that's still a number positive, not equal to 0, getting really, really close to 0 though. And that's the idea with horizontal asymptote. Let's take a look at the behavior of the function as the x values increase. In this case, notice that the increase in x, we start out with 2 and then 4 and then a y value of 8. So this is just when x is 3. So these y values get large pretty quickly on the positive side of x. One other thing we might take a look at in this table is the ratio of consecutive y values. That is, consider 8 and 4. The ratio of those two y values would be 2. 8 divided by 4 is 2. The ratio of 4 and 2 is 2.